Hello everybody and welcome back to another video. Now in today's video we will be looking at the HackTheBox intro to reversing track. But before we get into that, let's hear a short word from our sponsor SSD Secure Disclosure. And today I would like to raise your attention to the TyphoonCon CTF. This Capture the Flag event will allow you to battle amongst the other security researchers of this world to see how you place and where your skill level is. This CTF will feature some specially crafted challenges and some amazing prizes ranging up to $3,000 for the first place. Now, this CTF is actually organized by SSD Secure Disclosure. They're a company that helps researchers responsibly disclose and get rewarded for their zero-day vulnerability findings. What is left for you to do? Well, call up your friends, tell them, hey, from the 12th till the 15th of July, we are playing in the TyphoonCon CTF. Go over to the website, linked down below in the description, sign up and get ready and start to prepare for this amazing event. Now let's get back to the video. And today we will be looking into the Baby RE challenge, the baby reversing challenge. And the description of this challenge goes, show us your basic skills. PS, there are 4 ways to solve this. Are you willing to try them all? And in this video I am going to cover 4 techniques that you can use in your reversing to see which grant us a flag. First of all, we are going to be looking at strings. Then we are going to be looking at Ltrace. Following that, we will be covering some static analysis and then finishing off with some dynamic analysis. Now, before we go into those techniques, let's look at what this file actually is and what we can do. So running an ls, we see that there is this baby file. If we want to know what kind of file this is, we run file on that. And that shows us that this is an ELF 46-bit or 64-bit executable. So this is something that we can run on a Linux machine. Now, if you want a deeper understanding of ELF binary files, be sure to check out my video where I cover ELF files in depth, which will be linked down below in the description. But for now, we want to know more about this binary. So what better way to see what it does than by running it? And we will run it. And it says insert a key and gives us the option to enter something. So if we enter something, we see that we entered the wrong key and that the program just exits. Now, okay, let's jump into our first technique here, using strings to gain more insight in this binary. Now, what will strings do? Strings will take a look at this binary and find all of the bytes that match letters that will be readable to us. And it will print all of those bytes out. And that's what you can see here. So we have a lot of information about this binary here. And why do we want to do that? Well, this way we can find things that the binary can potentially print, things that can happen, and we can just gain more insight into what's happening. So it's always a very good first step to look at strings. And in this case, we see part of the flag, perhaps. We also get the text, don't run strings on this challenge. That is not the way. We have an insert key, that's a statement that we saw, and then we see this ABCDE 122313. Okay, so that followed insert key. So is it reasonable for us to assume that that might be the key? That we can try that actually, and let's run the binary again and insert that as the key. And we will see that that actually works and that we get the flag. And that is how we used strings to get the flag on this challenge. Next up, we will look at using Ltrace to see what we can find. Now, what is Ltrace? Ltrace is a utility that will run a command and then trace all of the dynamic library calls that are made. So dynamic library calls are things like puts, system, gets, all of these calls. It will track them and show them to us. But the best way to showcase that is by just running it on this binary. So we're gonna run ltrace /baby, and we will see that it starts with a puts. It's gonna puts insert key. Obviously that is what we expected. Following that, we will get an fgets. Now here we have to enter our input. So I enter ping draconian as input as the key. And we will see that once we enter that, it's going to accept a maximum 20 characters here, so that's all interesting. However, the next statement, this string compare, is really interesting because here it is going to compare our string, ping draconian, to ABCDE122313, which is obviously the key we now know from using strings. However, if we didn't yet know that, we can make a very educated guess that this would be the key. So after that string compare, we see it exits with 15, or it returns 15. And for string compare, when the return value is 0, the strings are equal. When it's not 0, they aren't. And following that, we get a puts try again later. Oh, very interesting. What happens now if we run Ltrace with that key that we think is going to be the key? So we do that. Again, we enter our key here, and then the string compare happens, and we see that the value, the return value from string compare is 0, meaning the strings are equal, and now we get the flag outputted. So that's how we used string compare to gain even more insight in this binary. And then we can move on to static analysis on this binary. And for that, we are going to be using Ghidra. So I've opened this binary in Ghidra, and now in the left here you have a symbol tree that contains functions, a list of functions. Now a lot of these functions are not useful to us. However, the main function is where everything is going to start. So let's take a look at that function. And we see that this starts off with exactly what we expected. But before I go into that, let's explain these windows here. So on the left here, we have the assembly. So this is the raw assembly code that your computer will understand. However, it's really hard to read for us. Therefore, Ghidra tries to decompile this assembly into C code. Now, this is an attempted decompilation, so the chances of this C code running and working like that are very low. However, this can give us a greater insight into what's going on. I mainly focus on the C code, and then when those things don't make sense, then I move on to the assembly. So looking at this decompilation, we see it starts off with what we expected, a puts of insert key. We are then going to get 20 characters from standard in, and we are going to compare those with string compare to this key that we already uncovered. If that value is 0, so if those are equal, then we are going to do this weird thing with some bytes and puts them, and that sounds a bit strange potentially. So here, let's look at the assembly code. So what is happening over here? We have these values, and if we hover over them, they will say what they mean in characters. So this first value means HackTheBox baby, but backwards. And the reason why it's backwards is because this binary is least significant bit, so LSB. However, for more on that, check the video in the description. Now, okay, then the second value will be another part of the flag, and so on. Now, what is happening here? Here we are moving those values. So we're moving RAX, which contains that value, on the stack somewhere with an offset. So moving them on the stack, we're moving the other value also on the stack, and we do that with all of these parts of the flag. Now at the end here then, we will load that area from the stack and puts it, so output it to the screen. And this is probably done this way to have some sort of obscurity. This is also the reason why the strings command did not just show the full flag, but showed it kind of in parts and a little bit away from each other. So this is kind of just that obscurity that is built in. And here is also a good example of where you should have some very basic knowledge of assembly to better understand what is going on. But that is what we have learned through static analysis. And now let's move on to the last part of this video. We are going to dynamically analyze this binary. So dynamically analyzing means that we are going to be running through this binary assembly step by assembly step and looking at what is happening in the memory on the stack, and that way figure out what this binary is actually doing. For this, I am using IDA. I really like IDA. You can download a free version online, so definitely check that out. However, when you open a program, you will see we get a view where on the left we have a list of functions. Then if I click the main function, because that's the one I want to analyze, we get this graph view here with the assembly code. Wherever we are making jumps, we have these lines that jump to a new block, a new part of the graph, and that way we can really nicely graph out which way our binary is working. But let's start off here by just setting a breakpoint in the beginning, and we do that using the F2 key, and then starting the program and running it. Now, when we are running, we can use the F7 key to jump into a statement and the F8 key to jump over a statement. So now I'm pressing F8 to run through this binary. And running through it in the beginning, we are just doing some setup. Here we are loading the insert key into a register. We are then calling puts, and after calling that, we will see that insert key is actually outputted to the standard out. Now we are setting some things up for our fget, so we're putting the amount of characters that we can maximally input in registers, and then we are calling fgets, and now we need to enter something. So in this case, I will enter pink draconian, and moving on here, we should be able to find this on the stack now, or input. So going to the stack view, indeed we see pink draconian on the stack. So now moving on, we are loading our pink draconian, no, we are loading this ABCDE string into RSI, and we are loading pink draconian into our DI, and then performing a string compare. Now from earlier, we know that the output of string compare is going to be 15, and if we look in EAX, we see that it contains F, which is 15 when converting from hexadecimal. Now this test is going to see if EAX is 0, which is not the case. If EAX is not 0, which is the case, so we are going to jump to this case, to this part, which says try again later. However, we want EAX to be 0 here, so that we jump into this part, which prints the flag. So let's just run that again, but this time enter the correct code. Okay, so we are moving segments, and now we can get going. So I'm just going to jump over all of this until we get to fgets, and then I will input the key and enter. And now when we jump into the string compare, we will see that EAX is 0, and we jump to this block here. Now this is where it gets incredibly interesting, because now we are going to start moving these bytes into RAX. So in RAX it now contains that bytes, in RDX it now contains this, and now we are pushing RAX on the stack. We've just done that. Now let's synchronize with our stack view to see what it contains, and here we see the first part of the flag, HackTheBox. Moving on, we will push RDX on the stack, and look, it just appended it to this on the stack. And if we keep on moving on, we will see that the full flag will be created here, and then it will be put in. REX will point towards that, and it will then call puts, so it will output our flag, and we now get the flag on the screen. And that is how we used dynamic analysis to look at this binary and to analyze what is going on at a more deeper level. Now, in this video, I've covered 4 really useful techniques. There are obviously many more, but this is a great place to start. Now that was this video. I hope you enjoyed it. As always, if you have any questions, feel free to comment below. If you enjoyed this video, like it, and I hope to see you back for another one. Take care.